Our next topic in the factoring module is about factoring trinomials with positive coefficients. We're going to jump right into the main idea here, which tells you exactly how to factor trinomials. Okay? To factor trinomials, which are polynomials with three terms, you reverse FOIL. Okay, remember, factoring is the reverse of multiplying. Okay, so if you look at this example here, when you multiply something like 2x plus 3 times x plus 4, you FOIL. You multiply first, outer, inner, last. And when you do that, you get 2x squared plus 11x plus 12. So now the question is, well, what if I wanted to factor 2x squared plus 11x plus 12? What if I wanted to go backward? What if I wanted to take this polynomial and come up with this product? Well, essentially what happens is you have to fill in the blanks in a guessing game. If you want to factor 2x squared plus 11x plus 12, you have to think, what two binomials could I multiply to get this polynomial back? Let's talk a little bit more about how we can fill these blanks in. So let's more deeply analyze how we would multiply 2x plus 3 and x plus 4. All right. If we want to understand reverse foiling, we have to understand regular foiling perfectly. All right, so if I asked you to multiply 2x plus 3 times x plus 4, you would multiply the 2x times the x to get 2x squared. You would multiply the 2x times the 4 to get 8x. You would multiply 3 times x to get 3x, and you would multiply 3 times 4 to get 12. But then look what happens here. The product of the outer terms and the product of the inner terms happen to be like terms. So they combine. In this case, the 8x and the 3x give you 11x in the middle. Okay, so let's turn to the problem of factoring this trinomial. Okay, what would we want to think in order to help us break down 2x squared plus 11x plus 12 into a product of two binomials? Well, if you look at the pattern up here, this 2x squared, right, this 2x squared right here, came from these two terms. It came from multiplying 2x and x. So whatever you put in these first blanks has to multiply out to 2x squared. Right? Now, where did this 12 come from? Well, the 12 came from 3 times 4. Okay? So in order to get this 12, you would need two numbers here that multiply out to 12. That's all well and good, but we have to make sure now that the inner terms and the outer terms add up to this 11x. So after you fill in your blanks using the 2x squared to come up with 2x and x, and using the 12 to come up with 3 and 4, you have to check and make sure that when you multiply the inner terms, 3x, and when you multiply the outer terms, 8x, that adds up to your middle term of the polynomial you're trying to factor, 11x. Okay? So in order to factor trinomials, it's essentially a guessing game where you fill in 4 blanks. The first 2 blanks here have to multiply out to the x squared term. The last 2 blanks have to multiply out to the constant term, but then you have to check that the inner terms and the outer terms add up to the middle term. So now that we understand that factoring trinomials is essentially a guessing game where we check all of our guesses, we need a good process to help keep track of all the guesses so we don't go in circles and keep guessing the same thing over and over and over. Right? That's what this box diagram helps us do. So let's look at the example that we've been studying for this whole topic one more time. If I wanted to factor 2x squared plus 11x plus 12, I'd have to follow these rules. Okay. Since the first terms need to multiply out to 2x squared, I know I'm going to have an x and an x here, and the numbers in front of this x come from the factors of this coefficient. We call it the a coefficient. So let me list the factors of 2. There's only 2 times 1. Now, these last terms have to come from the factors of 12 since they multiply out to 12. Unfortunately, for 12, there's a bunch of different choices. 12 is 1 times 12, or 2 times 6, or 3 times 4. So the question is, which combination of 2 and 1 in these blanks, and then factors of 12 in these blanks, so either 1 and 12, or 2 and 6, or 3 and 4, are going to ultimately check out and give me 11 in the middle? Well, to do the guessing and the checking very quickly, let me show you how this box works. Now maybe you think in front of these x's here you should put a 2 and a 1. Well, in that case, I'm going to put a 2 and a 1 in the first column of the box. Those are my factors of a. Now, maybe I think instead of putting a 3 and a 4 here, I should put a 1 and a 12. All right, so pretend you don't know how this factors and you're just guessing. A possible choice for these two last terms would be a 1 and a 12. Then you can test whether that gives you the 11x in the middle by multiplying the diagonals. 2 times 12 is 24, and 1 times 1 is 1. These do not add up to 11, so this will not work. I cannot choose 1 and 12 for these coefficients. Let me try another guess. Maybe I want to keep 2 and 1 for my factors of a, but instead of using 1 and 12, I want to use 3 and 4 for my last terms, for my factors of 12 here. Well, I can check if those work by multiplying the diagonals. 2 times 4 is 8. 1 times 3 is 3. Do 8 and 3 add up to 11? Yes. So this combination of coefficients will give me my factored form. And the way that it works is you read straight across the row. So the first binomial in my factored form is going to have a 2 here and a 3 here. The second binomial is going to have a 1 and a 4. So altogether, this box tells me that my factored form is 2x plus 3 times 1x plus 4. Okay. So we're going to be using these boxes all the time when we factor trinomials, and you'll see a ton of examples to help you get used to it. So here's the general procedure for factoring trinomials of the form ax squared plus bx plus c when you have positive coefficients. So we're going to deal with all plus signs first. We'll deal with minus signs in the next topic. Right, so the first step is to list all the factors of a. Right, so you'll be given something like we've been dealing with, 2x squared plus 11x plus 12. And your first step is to list all the factors of a, so maybe 2 times 1 in this case. Then you list all the factors of c, so 1 times 12, 2 times 6, 3 times 4 in this particular example that we've been working with. Then you draw a 2 by 2 box like this. All right. And in the left column of the box, you put a pair of factors of a. In the right column of the box, you pick a pair of factors of c. and then you check if that configuration is going to work by multiplying the diagonals and making sure they add to the middle number. All right? So let's go on and do some specific examples to help you get used to this procedure. So here's our first example of factoring trinomials using our boxes. All right, let's factor the polynomial, the three-term polynomial, 2x squared plus 15x plus 18. All right, according to the procedure, the first thing you have to do is find the factors of the coefficient in front, factors of 2. The only possible way to factor down 2 is 2 times 1. And then also you find the factors of the final coefficient, the constant coefficient. 18 breaks down to 18 times 1, or maybe 9 times 2, or possibly 3 times 6. Then, after you've broken down the A coefficient and the C coefficient, you have to figure out which combination of pairs of factors will give you the 15x in the middle when you refoil. The quick way to figure that out is to use the boxes. Okay? You're going to take this pair of coefficients and put it in the first column of the box, and then you're going to pick one of these pairs, let's start with 18 and 1, and put it in the second column of the box. Then to check whether that configuration works, you're going to multiply the diagonals. Okay. 18 and 2 cannot be combined to get 15, so this box doesn't work, this configuration doesn't work. Okay, well what if we flip the 18 and 1? Okay, so you always have to try to flip the second column and see if that works. Okay, well that doesn't work, okay, because you get 36 and 1, which still doesn't combine to 15. All right, so at that point we've tried 18 and 1 and we didn't succeed, so we move on to 9 and 2. All right, so if you put 9 and 2 in the second column and you multiply out the diagonals, you're either going to get 9 and 4, which doesn't check, or you're going to get, if you flip the 9 and 2, you're going to get 2 and 18, which still doesn't check. So then you go on and you check your last pair of factors, 3 and 6. If you put 6 on top and 3 on bottom, you get 6 and 6 when you multiply out the diagonals, which doesn't check. Okay. But if you put 3 on top and 6 on bottom, then you'll get 12 from this diagonal and 3 from this diagonal, which does check and give you 15 when you add them. Okay. What that means is this final box tells us how to factor this trinomial. Right? To factor 2x squared plus 15x plus 18, you're going to need the binomial 2x plus 3. Okay, so this guy, this first row, tells you how to get this binomial. And then the second row, 1 and 6, tells you how to get this binomial, 1x plus 6. So then you can write your factored form for the polynomial. It's 2x plus 3 times x plus 6. Now you'll notice in this example we went through 6 boxes before the last one finally gave us our factored form. As you do more and more of these factoring problems, you'll start to learn which pairs of factors will work and which pairs of factors won't. Usually I like to start with the factors that are closer together and work to the ones that are further apart. Right? Because you see the 18 and 1, especially this box here, when we used 18, it gave us huge numbers which are never going to combine to 15. So in general, I will start with the numbers that are closest together, like 3 and 6, okay, and work the opposite way. Okay, but I wanted to give you a worst case scenario in this example. I wanted to show you the absolute longest it could take to factor a trinomial if you have incredibly bad guesses. All right, well let's work some more examples to make sure we have this down.